Hi there, this is Penelope, and this is a short video on a question that we will do in class for MG5004 DE5418, but I thought I would also make the video of it as well. So it's a question where there is quite a lot going on. It's a related rates question, if you like, but it's an application of integration as well. So what we've got is we've got a hemispherical vessel, so a sphere, half a sphere, and it's got internal radius of 0.5 meters. So that's 0.5 meters across there, which means also AC is equal to 0.5 meters as well. If we look at AD is equal to 0.52 as well, rather than TWO. So AB is going to be the, if we call it H, if we call BD H, then AB is going to be 0.5 minus H. Now, after T seconds, the amount of water in the vessel is going to be 1 T litres. So that's after T seconds. Now we need to convert this from litres to cubic metres. So 1 T litre is going to equal 1 T over 1,000 cubic meters, just so that we match up the units. Okay, so what we've got is that the water is flowing in, so the water is flowing in at 1 times whatever change in time over 1,000. Now R, let's call this radius here R. So R, or R squared, is going to be equal to, just by ordinary Pythagoras, but we're kind of having to think about it in 3D, but that's okay, 0.5 squared minus 0.5 minus H squared. And if we do that, we see that R squared is equal to 1 minus H. We're talking about the volume, so we'll have a statement that says pi R squared times the change in height is going to be equal to the change in volume, it must be, which is 1 times delta T over 1,000. So this is the change in volume, must be equal to the change in volume. So let's set that out. Only let's call the change in H, let's call it dH, and then it kind of fits what we're doing. So we're looking for the integral between 0 and H. This is the volume formula of pi R squared dH, and we know that that must be equal to the same thing on the other side between 0 and T of delta T dt over 1,000. Now let's leave the 1,000 out of the right hand side. Let's put it onto the left hand side, and I think we'll need a separate slide for that. Let's multiply both sides by 1,000 and get rid of that fraction. So now we've got what we had before, like that. Okay, what do we know about integration? We've got too many variables there. We needed everything in terms of H, but we know what R squared is. We can put the pi out the front, so now we've got 1,000 pi Now r squared from the previous slide was 1 minus h times h dh, and that was equal to t. So on the left hand side now we've got 1000 pi times the integral. We need to multiply it out, it'll be a lot easier. So we've got h minus h squared dh is equal to t. So 1000 pi is now going to be equal to the integral of h is h squared over 2 minus the integral of h squared, which is h cubed over 3. And what we've done is we will integrate that with h and 0, but nothing happens as far as that's concerned. Don't change anything. So now let's get rid of those fractions. Let's put a common denominator in. So we've got 1000 pi is going to equal 3h squared minus 2h cubed over 6, and that's going to equal t. And let's get the 6. Well, we could put the 6 on the other side. It doesn't really matter where we put the 6, but we could say that 1000 pi is times 3h squared minus 2h cubed equals 6t. Done. We could factorize out the h if we wanted to. 1000 pi h is 3. In fact, we could take out h squared if we wanted to. It doesn't matter. Now, if you use the formula, there is actually a cheats way. There is a formula that says that the volume is going to be equal to pi h over 6 times 3r squared plus h squared. And we know what r squared is, so we can say that's pi h over 6 times 3 times 1 minus h times h plus h squared. And if you do the algebra, you get exactly the same answer. The 1000 won't be there, but that's fine, we can put it in. So it would be pi h over 6 times 3h minus 2h squared, and they'd need the 1000 in there as well. Okay.